Actually, we can probably do this. Okay. All right, so Clark said that this is, I'll do this, red. Okay, you said 5.5, negative 5.5. I don't like how that's writing. I'm going to do thicker than that. Okay. All right. What about number 6? What did you guys get for number 6? Hiya. Negative 2 and 0. Did anybody else get negative 2 and 0? Yeah, super. Sounds good to me. Cool. All right. I can't scroll down when it's like this. I have to do this, and then I scroll down. Got it. Okay, now we're cooking with garlic. Okay, now with this one, these are a little tricky. They give you an endpoint, and they give you the midpoint, and you want to find what the other endpoint is. Okay? I usually like to arrange things from left to right, and it really depends upon what order they give you your values in. So you might have a little bit different of an answer. It just depends upon where you put the endpoint. Okay? Dom?
I think you can scroll down if you use multiple fingers.
Can you? When it's in, oh, you can. Nice. Thanks for that. I appreciate that. All right. So what'd you guys do for number 7? Clark, what do you got, bud?
Negative 6, negative 5.
Okay, negative 6, negative 5. Did anybody else get negative 6, negative 5? Okay. So how'd you do that, Clark? Go ahead and articulate what you did for me. I imagine you looked at the difference between 8 and 1, right? What did you have to do to get from 8 to 1? Subtract 7. Probnor's helping you out.
Yeah.
So then subtract 7. So then what do we have to do again? Subtract 7 again, right? Which gave us negative 6. Okay, cool. And then what was your difference from negative 7 to negative 6? How do I get from negative 7
Sorry,
to...
I forgot how I did this. It's not.
Did you do it different than how I'm explaining it?
+1. Subtract. No, I just did it in my head.
Oh, gotcha. Okay. We're going to plus 1. So to get from negative 7 to negative 6, we do have to add 1. Think about number line. Like negative 7 comes before negative 6. You have to add 1 to get there. It's all good. So we'd have to add 1 again, and that would get us to what? Negative 5, right? Okay. All right. What about number 8? What'd you guys get for number 8? Probnor?
10 and negative 8.
10 and negative 8. 10 and negative 8 sounds good to me. What about you guys? 10, negative 8 sounds good. Good. You look at the difference between 2 and 6, it would be 4. So you'd add 4 to 6, and you get 10. And then the difference between 3 and negative 2 is negative 5. Subtract 5 again.
Seven.
Should be negative 7. Yep. It's okay. You said it so confidently, you confused me. So confidence is good. I'll take it. But the answer's wrong. 10, negative 7. That's what we're looking for. Okay? Otherwise, good job. All right. Now, how would I find the midpoint of a line segment? Haya, what'd you do? Yeah, and then just found the midpoint between the two. Angeline, is that what you did as well too? Yep, that's probably the best thing to do. So then, Haya, what were your, it looks like negative 5, positive 5? Yeah. Okay. I'm going to make this thinner. Okay, negative 5, positive 5. And then your other coordinate point was 3, 0? Yeah. Okay. All right, good. And then so between negative 5 and 3, what's your midpoint going to be between those? Good. Negative 1 and then 2.5. So best practice there, I would use midpoint formula, which remember, x1 plus x2 divided by 2, and then y1 plus y2 divided by 2 would give you the coordinates of your midpoint. Okay? All right, very good. Okay, find the length indicated. So we want to find the length of, looks like UV. What'd you guys get for that one? 12? Yeah, 12 sound good? Is that what you got, Liam? 12? Good. All right. And then number 11. Ooh, now we're working with x, right? What was the equation you guys set up for number 11? Tom, what'd you do?
Oh, I just did the hj equals hi plus ij, and I got x equals negative 8, and
You ended up with an answer of x equals negative 8?
yeah, and ij equals 2.
Gotcha. Does that sound good for the rest of you guys? Negative 8 and then a length of 2. Good. Yeah, so I'd set up an equation like 8 plus 2x plus 18 equals x plus 18. It was weird getting a negative answer for your x value, right? But then when you plugged it in context, it made sense. So, okay, very good. And then what about number 12? What'd you guys set up for number 12, and what was your answer there? Hold on. I can do it. I can remember your name. Landon.
Yeah.
All right. What'd you set up, Landon?
10 plus x plus 1 equals 2x.
Nice. And then you solved and got x equals what?
11.
Very good. You guys get x equals 11? Does that sound good? Okay. You need to find, I don't think it says find the indicated length. Oh, yeah, it just says solve for x. But of course, if you plugged it in, you'd be able to find what your expressions are, which x plus 1 would be 11, and then 2x would be 20. So, nice. All right, cool. All right, 13 was really similar, wasn't it? What'd you guys set up for 13? Hold on, I can do it. I know your name. It's right on the tip of my tongue. I forgot. What is it?
Julia.
Ah! Julia, that's right.
I did x plus 3 plus x plus 2 equals 13.
Great.
I solved that for x equals 9, and then ED equals 12.
Cool. Did you guys get ED equals 12? You got x equals 9 for your expression? Anybody else get x equals 9? No? Well, let's check it out.
I got,
I didn't find it.
yeah, I got 4. X equals 4.
Got it. Well, let's check. So x plus 3 plus x plus 2 equals 13. Combine your like terms. 2x plus 5 equals 13. Subtract 5 from both sides. 2x equals 8. You all right?
Yeah.
Your face is really red. Divide both sides by 2, you get x equals 4, right? Okay. All right. Questions there? We good? Okay. All right. Cool. Well, that's the homework. Let us go ahead and finish 1.2, 1.3. All right, yesterday we talked about midpoint as well too. We didn't really do any problems with midpoint on your homework. Or no, I'm sorry, that's not true. When it came to like segment addition postulate and finding midpoint with segment addition postulate, we didn't really do anything with that. But we'll definitely get more practice with that here soon. All right, so let's talk about distance formula. Okay, so the first thing we're going to do is we're going to look at distance formula in respect of an application you guys should already be familiar with. Okay, now in middle school there was, so this is I didn't upload this to Google Classroom, right? These are the same notes from yesterday. Do you guys all know how to find that? Okay, go to numbers and then your files and you should be able to find it in there, okay? If we need to talk about organizing files, I can help you guys out with that a little bit as well too, okay? All right, so one of the most memorable theorems that you guys learned in middle school would have been Pythagorean theorem. Normally when we use Pythagorean theorem, what shape do we use it with? Yeah, specifically a right triangle, right? Like a right-angled triangle. And what does Pythagorean theorem do? What does it relate about a right triangle? Dom?
Finds the hypotenuse.
Yeah, it finds the hypotenuse, or what it does is it just sets up a relation of the side lengths, right?
Yeah.
Now, did you guys you probably did A, B, and C, right? A squared plus B squared equals C squared. Which one of those letters typically represents the hypotenuse? C. And the reason why is because it's the one that's by itself, right? Now, I usually write the Pythagorean theorem as C squared equals A squared plus B squared. So you guys are going to have to get used to that once we cross that bridge. We'll study Pythagorean theorem again later in the year. We're just going to touch on it at this stage, okay? So the first thing we're going to do is we're going to use Pythagorean theorem to talk about distance between some values. So we have a coordinate point, -4, 1, and then 3, -1. We want to find the distance between the two, but we're going to do so using the Pythagorean theorem. Okay, you can't always do it this way, but I'll show you why this example works. Okay. All right, so let's see, -4, 1 would be right around here. And then 3, -1 would be, let's see, right around here. Okay, so this is E, and then this is F. Okay, so I want to find the distance between these 2 points. Okay, which means I want to find the length of this line right here. Oh my God, that's terrible. I can do it. I believe in myself. That's not that bad. Okay, cool. Now, how on earth am I going to use Pythagorean theorem to figure out what the distance between those 2 points is? I need a triangle of some sort. Haya, what are you thinking?
I went down to
Right. So Haya just drew a triangle out of that. And basically what she looked at is she went down 2. And if you compare our coordinate points, which is -4, 1, and 3. Oh, I don't like that 3. 3, -1. You went down 2 and then right a certain value, right? What does that down 2, that -2, what does that represent? Probnor? You went like that. What does that mean?
Down.
It goes down. Yeah, okay. What that represents is our vertical change. So we went down 2 units to get from one point to the other, okay? And then Haya, you said you went right how many values? You said what? 7. What does that represent? +7, which we would say is our horizontal change, right? So the down 2 and the right 7, that represents our vertical change and then also our horizontal change. So if I want to find the distance, which distance is always positive, right? How could I use Pythagorean theorem to help me out here? And we just talked about something with A, B, and C, right? Where's A, where's B, and then where's C? Haya? Good. We could say like this is A, this is B, and then this is C. So we could say 2 squared plus 7 squared, is going to be equal to C squared. Okay. All right, 2 squared is what?
4.
Nice. 7 squared?
49.
Ooh, quick math equals C squared. What's 4 plus 49?
53.
How would I solve for C? What would I need to do?
Square. 53.
Square, Angeline? Yeah, I have to take square root of both sides, right? Now, is 53 a perfect square? No, it is not. It's some value bigger than 7 because 49 is a closed perfect square and it's going to be probably like 7.14 or something like that. But you can leave your answer as the square root of 53. That is a good answer. If you really want to give me a decimal as an answer, you can do that as well too. Okay? All right. Questions there? Okay, super. All right, let's do actual distance though. Okay? Now, what we're going to do if we're trying to find the distance on the coordinate plane, the other way we can do it is what's called the distance formula. Bless you. So distance formula, if you have a coordinate point A and a coordinate point B and your coordinates are x1, y1, and x2, y2, those are points in the coordinate plane, you can use the distance formula and it's given as follows. Bless you. The square root of x2 minus x1 squared plus y2 minus y1 squared. You have seen this before, correct? You probably did it in Algebra 1, and you probably looked at it in middle school as well, too. The only part that's less than fun about this section is you just have to be really careful when you plug this into your calculator, okay? Because you got to be real careful with parentheses and negatives and that type of stuff. Otherwise, it's not hard. It's like, here's the formula, plug the values in the formula, call it a day, okay? All right, so let's find the distance between these 2 points now using the distance formula. Now, you saw yesterday, I like to label my points. So I'm going to label this as x1, y1, and then over here is x2, y2. Okay. And then once I have those labeled, I'm going to plug them into my distance formula. And you guys probably remember doing this in the past. Okay. It is an expectation of mine that you guys do have the distance formula memorized at some point, okay? All right, so the distance, we would say, is between EF. So the distance EF is going to be equal to square root of, all right, so x2 minus x1 looks like 3 minus -4 squared plus y2 minus y1. So then that would be -1 minus 1 squared, okay? Now, like I said, you do got to be careful about your negatives. Sparrow, did you forget your glasses today?
No, I'm fine.
Do you want to sit in the front?
No, I'm good.
You sure?
Yeah.
You don't want to sit in the front? The front's the best place to sit.
I can see.
Okay. All right. All right, mental mathematicians. What is 3 minus -4? 7. Okay, so I'm going to do this part slow at first. 7 squared plus, what is -1 minus 1? -2. So I'm going to put parentheses, -2 squared. All right, cool. 7 squared? Nice. Plus -2 squared? Hey, those numbers look familiar. What's 49 plus 4? Hey, that number looks familiar. Isn't that what we got earlier? Cool. So that's another way that you guys can do it as well, too. Pythagorean theorem is nice, particularly when you have a graph that's in front of you, but distance formula is the tried and true. Okay? We remember doing this in the past? Super. All right, cool. I didn't think this would be anything earth-shattering or new for just about any of us. So, all right. Questions there? I got a couple more examples. Now, again, square root of 53 is a good answer. But if we want to get that as a decimal, let's see. Calculator? Is there a calculator built into this bad, Larry?
Yeah, it's on the left bottom.
Oh.
Right there.
Let's see here. Welcome to Calculator. Oh, you can personalize it. This one looks cool. Choose button chip. I can't even see it. All right. Okay. All right. All right. You know what? I'm over this. Just talking about making an account, stuff like that, whatever. Cal.
Calc.
Oh, look at this guy. All right. Let's see. Oh, this is the button I'm looking for. Scientific. Oh, yeah. Now we're cooking with garlic. All right. So 53. And then is it the kind? Yeah. Okay. So you do that. Press enter. 7.28 is what we get. 7.28. All right. Questions there? When you guys take your state test, if this is an extended response question and they want you to find the distance, you can write your answer as square root of 53, or if you're comfortable working with decimals, then you can write your answer as a decimal. Either one's fine. Okay. All right. Next up. Okay. Find the distance between A and B using both the Pythagorean theorem and the distance formula. Okay. I'm going to give you guys the opportunity to do this on your own. So do it on your own. Now, if I do it using the Pythagorean theorem, what do I have to draw? Got to draw a graph because I'm going to draw a triangle on the graph, right? So you can go ahead and do that. Let's see, my x values are -10 and negatives. That's a lot of negatives. And then my y values are 2 and 6. So really the part of the graph we're looking at is here and here. All right, so -10. So when I go to make a graph, you can either, I mean, there's probably a way you could insert a picture of a graph pretty easily. Or, you know, just hand sketch a little graph real quick. If you were good at Pythagorean theorem, doing this one via Pythagorean theorem is a pretty easy route to go. The only downside of doing it with Pythagorean theorem and drawing your own graph is then you have to like really be careful about like counting the spaces. You know what I mean? Like your scale's got to be accurate in order for you to properly count the spaces. You good? Yeah. Okay. Just thinking. How we doing? Seeing some good stuff here. What's a good looking triangle? Okay. Hey, I drew a little bit of a graph up on the picture. So I plotted out like with my triangle, my vertical change of 4, my horizontal change of 3. How about this? Even without plugging it into the Pythagorean theorem, does anybody know what the length of that hypotenuse was? What type of triangle did I make? A right triangle. Have you heard of a 3, 4, 5 triangle? Does anybody remember that? So a 3, 4, 5 triangle is a common Pythagorean triple. Somebody remember that at all? So 3, 4, and 5 fit into the Pythagorean theorem in the following way. If the side lengths of your right triangle or the legs of your right triangle are a length of 3 and 4, your hypotenuse is going to be 5. So there's like combinations of 3 numbers that work really well with Pythagorean theorem. 3, 4, 5 is the most common one. 5, 12, 13 is another one. 7, 24, 25 is another one. So those are ones that you guys will develop and see. But either way, if you didn't realize it was a 3, 4, 5 triangle, then your next step is to just do 3 squared plus 4 squared equals c squared. Play that whole game, and then you would get 9 plus 16 equals c squared. 25 equals c squared. Take square root of both sides. What's the square root of 25? Bet your bottom dollar it is. So then 5 is the length of your hypotenuse, okay? And then if we do distance formula, same kind of thing happens. So I plugged it into our distance formula here, but I want you guys to tell me what type of values you got. So then when you handled your x's, what is negative 7 minus negative 10? 3. What's 3 squared? Nice. Plus 6 minus 2? Positive 4. And then 4 squared? 16. Angeline, you might have done like 2 minus 6, which is negative 4. But what's negative 4 squared? Still 16, so you get the same thing either way, okay? Now, do be careful. Whatever order that you choose your coordinates from for the first one, make sure you do the same order with the second one. 9 plus 16 gives us what? Which happens to be a perfect square of 5. How are we feeling about that?
Good.
We good? Yeah? Okay. All right. I got one more example. we'll just do it using distance formula. Okay, so find the distance between C, -2, and D, which is 3, 4, using both the distance, or it says using both the distance formula. It probably means and by Pythagorean theorem. You guys don't have to do Pythagorean theorem. Just do it using distance formula, okay? Like your shoes. Probably should have wrote that on the board for you, huh? If you forgot what the distance formula was, I'll write it up here for you. Another equivalent form of distance formula is x1 minus x2 squared plus y1 minus y2. As long as you're consistent with the order that you pick your coordinates, then you should be perfectly fine. Cool. All right, even though you may not be done, help me out. When you put your numbers into the distance formula, what numbers am I putting in? What am I doing first? First set of parentheses. -2 minus 3. Okay, so you did x1 minus x2. Did anybody do 3 minus -2? Yeah, that's probably what I would have done. But you know what? Julia, you said -2 minus 3. I'll play your game. Why? You didn't do it wrong. You're still going to get the same answer.
Oh.
Yeah, we're.
Does it matter? Why is it written that way?
That's a good question. Okay, so you see how I wrote the distance formula up here, x2, x1, and then y2 minus y1. When you label your points, it's best to do it from left to right. So if you look at like your x values of your coordinate points, the first one is -2 and the second one is 3. Which one would be the leftmost point? -2, right? Because that's further left on the number line. So I would label that as x1, y1, and then this is x2, y2. But the key part is, like if you did -2 minus 3, that's fine, as long as your second set of parentheses you did -2 minus 4. Which, did you do that?
Yeah.
Yeah, you'll get the same answer as anyone else. Okay? So I'm playing your game. -2 minus 3 squared plus. All right, and then the other one, Julia said she did -2 minus 4. Can we not play my game, she says. All right, -2 minus 3, what's that going to give you? -5. Plus -2 minus 4 is... Okay, you square -5, what do you get? 25. You square -6, what do you get? What is the sum of 25 and 36? You said what? 65? 61, I think is what it is. Should be 61. I think a negative might have got you somewhere, Dom. Go try to find that mistake. Is 61 a perfect square? No, not in this class. Let's see. 49, 64 is a perfect square, right? That's 8 squared is 64. So then as a decimal, it's probably like 7.89 is my guess. Clark, what do you have to say? Not right now. So somewhere around 7 point, I don't know, just south of 8. Okay? You find it, Tom?
Yep.
Okay, super. All right, questions there? We feeling all right? Okay. What I want you guys to do is 1 through 4 and whatever the last one was on your worksheet, like 14 or something like that. Okay? There is no reason why you should walk out of my classroom with any homework. Okay? What time? You got 15 minutes to get those done. Okay? We're just going to go ahead and do a check at the end of class. So 15 minutes, you have to do 5 problems. You can do it. I believe in you. 3 minutes a problem. Okay?
Does it matter if we use not questions? Okay, first one. Oh, I got it.
So again, we'll do a review on Tuesday, quiz on Wednesday.